So when you reach the level of Bruce Mao, you need no introduction, and in this case, that is the truth. I'm going to give you Bruce Mao here to start the talk.
Okay? Thank you all for coming out this afternoon. I'm here in a kind of dual capacity as a fellow in the Siegel Design Institute and also as an adjunct professor with my colleague Tammy Gaber from Sudbury, from my hometown in Northern Ontario. There's an architecture school there called the McEwen School, and I went back and I was asked to be on the board of the school, and I've been working with them for several years. And this is the first year that I'm actually doing a course, doing a studio with them. So we have a dozen students here from Sudbury, and my assignment for 10 days is to blow their minds, and so you're all part of that entertainment. What we're doing together is actually a really quite extraordinary project. There, in my hometown, when I was a kid, there was a 30-mile dead zone because of the mining activities and the actually more because of the smelting activities. They had so polluted the environment that literally not a blade of grass grew. And when NASA wanted to train their astronauts to actually collect rocks on the moon, they brought them to our hometown because it was the closest thing on the planet to the surface of the moon. When I was a kid, I remember seeing these guys by the side of the road planting stuff in the desert. And it really was a desert, like literally nothing. And every year, everything died. And I thought, wow, these are like the losingest farmers on the planet. Who are these guys? And it turned out that they were scientists trying to figure out what it would take to recover that ecology. And they did figure it out, and they did do it. And a few months ago now, Jane Goodall came to our hometown and planted the 10 millionth tree. And they have planted 10 million trees. They estimate that there are now 100 million trees because of that. And they've recovered this ecology. It's an absolutely extraordinary accomplishment. And their project, our students' project, is to build a kind of monument, celebration, kind of testament to this accomplishment. And especially a kind of declaration going forward. And so that's what we're here working on. And so as part of that, we're gonna introduce the Nexus, and I'll hand it back to Julio.
Okay, so yeah, everything that we are going to tell you is somewhere in the book. The book is about two things: augmentation of thinking by joining up, or what we call the new convergence of art, technology, and science. And since ideas have to be implemented in the context of the real world, and the world is complex, is the other title above, that is augmented thinking for a complex world. So we'll try to go fast, but let me start with one example that is somewhere in the middle of the book that represents a good example of the intersection of art, technology, and science, and the importance of context. Okay, it's one historical example. It's old. It has to do with the person who basically invented modern physics, which is Galileo. So the Dutch have fabricated instruments that they were called optical tubes. And the reason for the existence of optical tubes was to sell them to armies to see advancing troops before it goes too late, or ships. No one had the idea of pointing them to the skies. Why not? Because the skies were supposed to be immutable. Aristotle had said that. No point in looking at something that wouldn't change. But almost at the same time, Galileo in Florence, or Padua, he was in both places, and Thomas Harriot in London decided to look at the moon. It was, for most people, it would have been a waste of time because the moon was supposed to be a perfect sphere. Now, you can see it with your naked eyes that there are spots. There were all sorts of theories as to why those spots were there. Maybe they were the inside. There was sort of alabaster substance and reflected that or reflected the Earth. So the point is, Harriot was in London, Galileo was in Florence, but there was a huge difference between Florence and London at that point. In Florence, Galileo had the Accademia del Disegno, and almost everybody who was a painter, a sculptor, architect had to go through training in there. They did exercises, almost theorem-like in perspective, like the ones that you see there. And Galileo eventually was admitted to the Accademia del Disegno as an artist because he was an accomplished watercolorist. So both look at the moon with similar instruments, and both drew what they saw. Those were Harriot observations, ink, pen, and Galileo's watercolors on the other side. But there was a huge difference in between the two. Harriot probably was a good astronomer. Galileo was a physicist, but also an artist, could draw things more realistically, but also with the training that he had in Florence about perspective, he could see the shadows evolving, and he could even calculate the height of the craters in the moon. So having the same thing in front of your eyes, someone would be able to go further. But why did he go further? Because he was in Florence. In Florence, that was what was in the air, this intersection between art, technology, and science, and the importance of environment. So what we're going to tell you are some things connected with the book. But first, let me tell you, for the people who are not here, how is that we ended up collaborating, okay? In 2006, there was an exhibit at the Museum of Contemporary Art. This is one room. And basically, Bruce Mau had taken over the Museum of Contemporary Art. And I was blown away, not by the messages, by the ability of putting all of the things together. This is another room. And I decided I have to meet him. And he was based in Toronto. And then I discovered that he was moving to the US. Then I discovered that he was moving to Chicago. I was overjoyed. And then, of all places, he ended up moving the house almost across of mine. So we have been working on this. Bruce described this as 12 years of coffees and maybe 2 years of Zooms. By the way, if you want to know more about Bruce, you can purchase this in Apple Plus. Two Austrian filmmakers followed him for 2 years, and they did this movie about him. So this was the dream combination.
And from my side, it was a kind of equally inspirational opportunity. You know, when Julio, when we met, Julio asked me to be part of what was happening here, and I was really honored to be included in this. And when I looked at what Julio has done, I was really blown away, because you can see, he has, first of all, two passions, which is art and physics, math, the kind of both sides of the brain, really. It's that kind of duality that we talk about. And he really brought those together. He published a book that really established him as one of the most important thinkers in complexity and the science of chaos. And then, as you can see, he makes absolutely beautiful images. He solved the problem of mixing. So he really kind of figured out, what happens when we mix things, and what is the mathematics of that, and appeared on most of the important journals of science, and was inducted into the most important academies of engineering and science. And so you have this, quite extraordinary fellow in your midst.
Okay. So why did we do the book? Because there are big problems to solve. I'm going to click to some of those. Bruce can make a commentary.
So what we saw is that the kind of challenges that we face are just increasing every day. The kind of complexity, the nature of the problem. As we go from about 1.5 billion people to 8 billion in the last century, and now on to 10 billion, the kind of challenges just keep getting more and more complex. And those challenges make the way to solve the problems. We have to find new ways of thinking, new ways of solving those problems. So if you think about just a kind of one cluster of those, that everything is connected, the connectivity is changing the rules, and the waves of innovation are becoming shorter, just that alone changes everything. And so you've got a whole new world, and the idea that you can kind of confront that new situation with kind of tools and thinking of the past just isn't plausible. And so, what we really need to do is to augment our thinking. We need, in a way, kind of new spaces for thinking, and that's really what Nexus is all about. The kind of challenges are unprecedented, and therefore we need unprecedented ways of thinking. We need kind of new spaces, and to create those new spaces, you need to kind of open up new territories. You need to kind of combine things in ways that haven't been combined before. And really, what we realized was that there was a place, when you looked at the world and who was actually able to deal with those problems, we saw that there were people who had mastered the languages of art, technology, and science, and were able to bring them together. And those were the people who were able to really confront these new challenges. And that ultimately we need to produce people like that. That's really the kind of challenge that we have.
So the book contains lots of topics. All of these words are somewhere in the table of contents. The larger font means probably more prominently. And I'm going to we are going to give you a sort of bird's eye view of what's in the book. But ultimately, as you will see, the book is about understanding different ways of thinking, understanding how someone else thinks. Okay, so these are all things connected with the contents of the book. But now, let me go to what is a central point in the book. Okay, so many of you have seen curves like this of an idea started usually in technology, advancing quickly, and then reaching a plateau where the things saturate. And if I show you examples of any technology, in here, means of recording information from writing on papyrus and vellum to storing things in the cloud. If I show you all of these, and even if you come from outer space and you ask a few questions, you can put them in some kind of chronological order, okay? Sometimes there are jumps in this within one line of thinking. So, for example, 1912 Harley Davidson, 1 cylinder, a leather belt. 1913, 2 cylinders, and they milk that until now, chain belt. And sometimes knowing a lot about one technology, all the knowledge that you have accumulated doesn't prepare when you go to the next thing. So everything that you know about combustion engines goes down the drain when Harley Davidson has to go to e-bikes. So what we are talking in here is about thinking modes. And one thing that the book has a lot of is a visual art as a backdrop. Okay? And why visual art? Because normally in visual art, we tend to equate, especially if you are not into art, you tend to equate the end result with explosion of creativity, inspiration, epiphanies, that kind of thing, which is really not the case because the trail survives. Within the production of any artist, you look at how something was generated and you find 10, 15, in this case, Guernica in Picasso, 43 sketches that survived before Guernica became Guernica, okay? But if I show you a collection of paintings in here in between 1910 and 1988, and I ask you, these are snapshots of time of different people, I ask you to put them in chronological order. This is very different than technology. You will not be able to do it unless you have taken courses in history of art. In fact, if I ask you which one is the oldest, which one is the newest, it will be hard. By the way, this is the oldest, Kandinsky. And there are 2 paintings, for example, we can do a show of hands, which artist did the same 2 paintings. Again, it will be hard because one of them is this, and the same artist did that one, okay? Now, there is more technology. There's almost no technology here. I mean, art historians will look at pigments and that kind of thing, but there's more technology in designing chairs. Every designer, architect has designed a chair. You can design a chair. What's the catch? Your chair cannot be like any other previous chair. You have to create your own space. But even ordering this, maybe this side of the table can do it, or other people here, but this is tough, okay? So we have this elemental kind of sigmoidal thing, And in technology, you don't wait until one technology disappears before replacing it. You are starting a new company, you try to replace the previous idea, and eventually the ideas join up, and this is more or less how science evolves. Science is methodical, there are no dead branches in the history of science, they get eliminated, and there are revolutions. The revolutions are infrequent. Quantum mechanics could be one, if you go way back, Copernicus revolution. They are infrequent, and you go forward, marching upwards. The idea of progress in science is kind of embedded in the concept of science. So that's science, technology. What's art? Modern art is more like this. The idea of progress is hard to define, okay? And in fact, now everything is going on at once. It would be possible in the past to recognize periods, but I love this quote from Peter Skeldal from the New Yorker. Everything is going on at once. And that's what we want, the chaos associated with this growth. The idea that you have to create your own space is a good thing. And you will see that it's no accident that we put art here, technology, and science. Technology, by whatever measure you pick, and Bruce will get into that in one chapter, technology always draws from art on one side and science on the other one. So what we're talking in here, this is highly simplistic, is what thinking skills are required to operate in this space. And you can draw from these two extremes, what we call left brain, right brain. Left brain being metaphorical, rational, logical, right brain being more divergent, creative, more images, whole, as opposed to parts. And the Nexus thinking, what we're advocating here is augmenting your thinking space by drawing from both sides at the same time, okay? So the keyhole, the point of the book, if we can convince people on understand how other people think and not equating them with the end products of what they produce, then we have reached one of our objectives, okay? So let me give you one example. We could pick a lot of examples, but this happens to be one of my colleagues in here is Mike Rakovitz. Mike Rakovitz got the commission of designing the fourth plinth in Trafalgar Square. It's a very sought out things. Artists would love to get the commission of designing something for the fourth plinth in Trafalgar Square. And this is what he decided to do. Rakovitz is Jewish, but Iraqi. So he thought this is the end product of what he did. But what he told me was that he remember this is what they see in history books, the winged bull. Well, that winged bull, there is one in the British Museum and other ones. But one of the most famous ones that existed in Iraq was destroyed by ISIS. And so what he thought was, it happens that the dimensions of the plinth were almost identical to the dimensions of the winged bull. So he decided to do something like that in there. But part of Trafalgar Square is about recycling things. There is a monument by Lord Nelson which involves recycling cannons. So he wanted to recycle something in there, and what he wanted to do was the thing that was the most, according to him, the thing that Iraqis outside Iraq long the most, which are these dates. So he imported, I don't know how many, tens of thousands of kind of dates, and he built the bull actually with a kind of dates. Now, in order to do that, he had to think on how to put a scaffold for that and doing those things. But the winged bull didn't appear just suddenly. This was a project that took years to produce. Now, we want to convey some of these ideas in the book. And the question is, how is that we can organize the book?
So we want the book itself to be a Nexus project. We want the book to have the experience of Nexus and be the kind of synthesis of art, technology, and science itself. And so the book is organized. You can see this is basically the kind of chapter structure. But it opens, before you get to the contents, it opens with a kind of almost like a cinematic credit sequence. So we introduce a whole series of projects that are Nexus projects. So you're kind of introduced to this new culture. And it ranges from the glass at Harvard, the project to make replicas of natural objects in glass that are actually perfect replicas. I mean, they're practically indecipherable from the real thing. To robotic sculpting, to a project by that is the new capsule for the SpaceX rocket. And you can see that real kind of synthesis of art, technology, and science. Then we have a contents page, and the contents page in this case is unlike any I've ever done or seen anywhere. I think it's 16 pages, and it basically goes through the entire book, and you can kind of take the whole book in just by reading the contents page. Then we go chapter by chapter, and each chapter introduces a new concept. And the image text synthesis is super detailed. And we'll go to the next page. And so one back. Everything that we've done is to make the reader an environment. It's as if they're inside of the idea. And the whole idea is to kind of synthesize that as smoothly as possible. So there are no footnotes. The notes are on the side, and they follow along with the text. It means that they can be much bigger. And so the writing is actually kind of synthesized as well in that way, so that you can kind of follow the big story in the main text and take kind of departures in the side notes that relate to the image material that is also there. And so the whole thing is designed in that kind of synthetic way. Each chapter opens with a kind of major project that is itself a kind of emblematic project of Nexus. So in this case, this is a project that we worked on. Actually, it's called Dreamscape. It's a kind of an immersive learning project. But in each case, we're talking about a kind of introducing one of the main concepts, an image that emblematic of that, and then a caption that kind of takes it to the next level. In the case of Chapter 4, what we've done is really kind of intense analysis of the three domains, art, technology, and science, and then the kind of what each dimension of those domains, how it behaves, and how it is different or the same across all those different dimensions. There are, I think, 43 dimensions.
Don't remember that.
And so each one you can actually see, how does, what happens in science, for instance, in terms of advancement. How do you advance your career? It's very different in science than it is in art or technology. So in each case, we follow one of those dimensions.
More chapter, one more.
And so you can see how all that works. And then it ends with another kind of image sequence that is a kind of outgoing cinematic sequence that ends the book with another series of major Nexus projects.
So one thing that is healthy, in our view, is that Nexus thinking, by drawing thinking from different domains, sometimes would produce conflicting views on how to address something. And the ability to solve those conflicts and getting used to address points that may be opposing each other, I think is an essential characteristic of innovators and leaders. So one thing, there is one chapter about lessons that cross domains, a consequence of that, analyzing those columns and the rows. And there are lessons from art that transfer to technology and science. They are the most appealing from the point of view they are purely visual. So I'm going to give you a few, okay? So one that we have is this series of lithographs from Picasso. And this is the last one that we have in the sequence. He did 11, we show only 8 in here. Now, unless you have been paying attention to the dates, the way that Picasso did this was the first, and the second, third, and so on, and this being the last. So what's the lesson in here? The lesson is, if you think the full bull with every detail, fur, and so on, representing complexity, what Picasso did was to go from complex to simple. And then in many problems, you want to go from the kernel of an idea and study the ramifications. There are people who are good in doing one, not the other one. You have to train yourself to be good in both. And have to be able to see simplicity in complexity, complexity in simplicity, and sometimes both at the same time. So that's the thing in here. Now, there are also lessons that go the other way, from science into every aspect of life. And there are lessons that cross domains. One chapter is devoted to complexity. And to talk about complexity, who happens to be what I do as research, you have to distinguish between two things. Things that the language, at least in English, is not rich enough that there are many words to distinguish these things. We use the word complex many times. In here, I'm going to define exactly what I mean by complex and complicated. So what we mean by a system that is complicated is a system that was designed with a blueprint. Every part fulfills a function, is locked into that function, it cannot change. So if you don't want to risk the system going down because one part failed, like in a nuclear submarine, you have to back it up several times. So a jetliner, a clock, and a circuit, those are complicated systems. Complex systems are systems in which the parts could be all similar or different. Like in the brain is all neurons. A school of fish is all fish. But something happens when the pieces interact. You can study a fish to death and never uncover the fact that they can organize in a school of fish, like the picture in there. Or you can study a neuron to death and never, ever uncover how consciousness emerges. But there are differences in here that go beyond the blueprints, the user manual. These things tend to fail all at once. The things in here are more robust. They can fail more gracefully. And also the parts can learn from context and adopt a new function, like stem cells, for example. They will learn from context. So this is how many things are. Organizations, ecologies, the world is not complicated. Design and lock in place is complex. But the key difference is this. You go from elements, fish or neurons, to this, and this is what is called emergence. Emergence is what makes a complex system, okay? So there are lots of lessons. You can list them, and we listed them in the book. And they are, the two that I am highlighting here are that chaos and order can coexist. Those would be things that would be considered diametrically opposed. They actually can coexist within a system. Depends on the scale that you look at, even the time scale. And the other one, which is super important, if this was next week, we have to give a talk in the business school, is that organization can emerge without central control. In fact, I would say that the role of a leader is to create conditions for successful emergence. You want ideas to emerge bottom up rather than all of them dictated with the master plans from above. So the idea of two things coexisting at once, this has been around for way more than 100 years, from quantum mechanics, light, the duality of light being particle or wave. Light is one thing. It behaves in different ways depending on what you expose light to. And so those are lessons that come from the complexity side into, let's say, when you talk with artists, I have found that they are fascinated by these ideas. But there are more lessons from art. And let me just show a couple, because one of the things that we have to overcome is the misconceptions that exist from one domain when they look at the other one. Okay? One is the creativity epiphanies coming from art. So in here we have 5 sketches. There are many, many more from Matisse to what eventually became this, that is regarded as the final painting, is in St. Petersburg, La Danse. There is another version at the moment. But Matisse had a long, long career. We in the book, we examine people who have had long creative careers. But not every day that he went to the studio, he was inspired. So some days he went to the studio, the painting was lying around there, and he painted the painting. Okay? So what's the lesson? Inspiration is overrated. Okay? The inspiration exists, but it has to find you working, Picasso said, and it's completely true. So another example from Picasso, this is also at the MoMA in New York. This was all done with found objects. Pot, pans, handles of pitchers. It's a bronze casting, but all produced the mold with all found objects. And you can see the head of it's called Baboon and Yang. The head of the baboon was 2 toy cars. And once you see the baboon and you see the toy cars, the two things blend. It's not like you see the toy car separately. So the lesson in here is adapting things, making them part of a whole. The whole can be the creative idea. The parts may not be. Usually, copying things is the way to move things in technology. There is nothing new technology behind an iPhone when it first appeared. They are all known, the pieces. What was masterful was the organization of the whole thing into a nicely designed object. Okay? So, by the way, this quote, the bad artist copy, the artist still, and many of the quotes there, we attribute to the historical people who we imagine said that. Okay? So it's not clear if Picasso actually said that. But Fitzgerald, who was this? Eliot, T.S. Eliot, the poet, writer, said something very similar to this, probably before, and was, in mature poets copy, mature poets steal. Okay, which is very similar, and that one is in writing, and we know exactly when he said it. Okay, so those are some of the transfer lessons that you see in between domains, and in some cases, some organizations, industries, we give examples of a few in the book, have managed to do everything at once, and this is one of them.
So this is an absolutely extraordinary document. It's an outline of all of the work that has been produced by George Lucas. So this is all of the kind of projects, technologies, businesses, cultures. So there's a kind of central spine here, which is Lucasfilm. Then Industrial Light and Magic down below. Sound, Skywalker Sound above, and LucasArts above that. And they're color-coded by people, companies, technologies, film, TV, and games. And you can see that one person who really was a Nexus thinker, who really was capable of synthesizing art, technology, and science, in some ways better than practically anyone of the last 50 years, was able to produce this extraordinary body of work and an absolutely massive wealth that went with it. He sold just one piece of this for $5 billion recently. And that doesn't include, all the, all the things that, all the things that came out of it down below and above. And recently, they've started construction on his museum, which is a museum of narrative arts, which is like the Museum of Nexus. In Los Angeles, and it's absolutely extraordinary. Can you go to the next slide? Mm-hmm. You can really see that it is a kind of, again, that kind of synthesis of art, science, and technology that is, his kind of way of thinking. And for me, it's just a kind of proof of the potential of this way of working, and what happens when you bring teams together. I mean, what he was really masterful at, not only was he himself a Nexus thinker, but he was masterful at bringing the teams, bringing Nexus teams together to do the projects across the spectrum.
Okay, so you are all here to augment the libraries that you have in your brains, acquire content. That's what education is. And there are periods in which you acquire lots of these volumes in this library. Maybe you get another degree, the library gets expanded, new classifications appear. And as we age, you see that there are people who have difficulty in filing something that comes before them if it doesn't fit really well in some niche in the library. And these are people who don't typically have reserved space in the library for things that to be filed later on or maybe discarded, okay? So we go through life looking at things with a lens that is informed by that library, and we can be successful. The question is, could you grow the library and acquire an augmented pair of glasses? It's easy in life to see everything with one single pair of glasses. Things tend to be black or white. But if you want to enrich your life, it's important to understand how other people think, and that will lead to much better, we believe, a broader thinking space. The broader the thinking space is, the more likely is that creative solutions will emerge. And then you have to train yourself or be part of a team in which there are people, a Nexus team, in which there are people who are good in executing the ideas. Presumably you can be both, the ones who create and execute. If not, everything that we said applies to teams as well. We believe that there are Nexus teams as well as Nexus individuals. So I guess this is all that we have. So thank you for your attention.